And this is session 6 and it is continued from session 5. Here is a man who is wearing a hat whose length 12 centimeters extending before face, and rain is falling vertically downward with a speed 10 meter per second. So let me assume such a kind of one picture. Say this is the hat of the person. Here is the hat of the person, and here is his face. Okay, so here is his face. So quite difficult to draw. Well, let me try that. Well, this is the face of the person. Okay, so this length is 12 centimeter as it is said in the question, and whose face is 16 centimeter down, like this, 16 centimeter down, and rain is falling like this. This is the direction of the rain, and whose speed is 10 meter per second. So if the man starts to move like this with some speed Vm, so how much maximum speed he can acquire so that none of the raindrop is able to hit his face. So this is the condition. Okay, so no raindrop should touch his face even though he is moving. So as soon as the man starts running and rain is falling vertically downward, well, so at that situation, so rain is falling vertically downward with velocity say Vv, and as soon as man starts moving in the said direction here, so rain will get the relative with respect to the man like this. So this arrow mark is showing relative velocity. Okay, so relative velocity of the man sorry, it's of the rain with respect to of the rain. Okay, so of the rain with respect to the man, with respect to man. So at this moment rain will get some horizontal component of velocity. So this is relative horizontal component of rain with respect to man. So in this circumstance, this Vv has nothing to do with the velocity of the man. That means Vv still it is 10 meter per second. So assuming this one, so I find how much time. Okay, so how much uh, time is needed. So time is needed to fall 16 centimeters down. 16 centimeter down. Okay, so this is what I find. So for this I use this vertical velocity. So the vertical velocity is 10 meter per second. So that is equals the length of the face should be written here. So the length of the face is vertically, that means 16 centimeter. So the time taken should come down because speed is equals distance divided by time. That is the formula I am using. So let t is the unknown time. If I rewrite this one, so this will be t is equals some 16 centimeter divided by, if I write this one in terms of centimeters, this will be 10,000, 1000 centimeter per second. So if I use this one here, so this will be 1000 centimeter per second, and the term second goes up. So that means t is equals 4 divided by 250 seconds. So in this time, so the rain will come down 16 centimeters. Okay, so this will take how much time? So t is equals 4 divided by 250 seconds. So in this time, if he moves 12 centimeter, okay, in this time, if he moves 12 centimeter forward, so definitely rain may hit his face. Okay, so that means his speed should be such that his horizontal motion in this time should be less than 12 centimeter. Okay, so to avoid rain, he must move horizontally, horizontally, uh, no, horizontally less than 12 centimeter in 4 divided by 250 seconds. So that means his speed Vm must be less than 12 centimeter divided by time is 4 divided by 250 seconds. So this is how we can write. So on rewriting it, this one, which is 250 divided by 4 into 12 centimeter. So if I do so, this is 3. So this will be is equals 25 3s are it is 750. Right, here is one more 0, so that 0 750 centimeter per second. So I forgot to write the second in the denominator, so it will come down this much. So this can be written in a different way also. That means I'm taking the centimeter out, so this will be 7.5 meter per second. So our answer should be this one or this one. So this is in centimeter per second and this is in meter per second. So if you observe all these given options, all options are having units meter per second. So definitely the right answer is this one, which confirms our answer. So this is how we have to solve this question. Here in this question, there are two persons, A and B, are running on a straight track and in same direction. They observe a car. So A says that the car is moving in east direction. Okay. So A says car is moving in east direction. Whereas B says that the car is moving in north direction. In the north direction. But one thing they tell common, that is speed of the car. Well, so they say the speed of the car is same. A says car is moving in east and B says car is moving in north direction with the same speed. Same speed. So these are some clues about the problem. If the speed of B is double that of A, okay, so speed of B is double that of A, like this. So we have to find the true direction of the car. So the actual direction of the car should be expressed finally. So among these four choices, one is the best one. That is what we have to find. Here we are having only one choice correct. Okay, so only one choice is correct. So what we have to do here is, let me say my convention. If I say this is the north direction, the navigation menu. So this is no doubt east and west, south. So using this configuration, I write, so I choose this as the x-axis and this as the y-axis. So all x-axis vectors possess a unit vector I cap and y vector y in y direction is j cap. The unit vector is j cap. So I said the conventions what I am going to use further. So I'm solving this question in a trial and error manner. So I assume first I assume, okay, so first I assume, the VA, the speed of the person A, is written as VXA I cap plus YA J cap. Meantime, the uh, velocity of the person B is similarly written XB I cap plus YB J cap. So nothing has been said about their direction of motion. So in general, they are talking in the problem. So we have to assume some expressions for their velocities. So this is what I am assuming. Meantime, now for a car, okay, so uh, for car, I am writing. So it is VC is equals, so it is XC I cap plus YC J cap. This much I can write. But they are saying, A only sees the car is moving in east direction. East means x-axis. That means only the car's x coordinate will change with respect to A, and y coordinate remains as it is. So that means what we can say, what we can use means what I can write. So YC must be is equals to YA according to the given clue for A. And B watches the car which is moving only in north direction, right? So only in north direction. Only in north means this one Y. So Y coordinate only change with respect to B. That means only these two things will vary with respect to B, and these two things remain same. What I can write then, it is XB is equals XC, or XC is equals XB, whatever it is. So now I'm rewriting the same equation. Okay, so rewriting the same equation for car. So this is VC is equals, now what I can write, it is XB Y cap plus YA J cap. This much thing I can write. So the final equation for the car velocity is here. Okay, so for further I am using this as a reference. Now I do what? I find the relative velocity of the car. Okay, so relative velocity of a car with respect to A, with respect to A. So how I can write? So this is VCA. So VCA is equals, what I can write? With respect to A, I'm talking about. That means XB minus XA. Okay, so XB minus XA into I cap. But what happens here, y coordinate of A and car are same. So the subtraction makes 0. So no need of writing anything further. So similarly, relative velocity of a car with respect to B, that can be written like this, So it is VCB is equals. So what I can write is, XB for car, and for the person B, these two terms XB and XB get cancelled. So the remaining terms are YA minus YB. So that means YA minus YB into J cap. This is what I can write. So further what I do, we are having some clue. That means velocity of these two guys are same, like this. That means VB is equals 2 times VA. This is how I can write. These two terms are equal. 2 times VA is VB. So by using this convention, I can rewrite the magnitude of VA something and VB something, that is by using this formula. So I am writing now. It is XB square plus YB square under root is equals 2 times this one for this VA. The magnitude is XA square plus YA square under root. So when you solve this one, so definitely we will get XB square plus YB square is equals 4 times XA square plus YA square. So if I assume now YA is equal 0, if I assume YA is equal 0, so then what happens? Right. So if I assume YA is equals 0, then we can rewrite this equation, okay. So this one as a XB square, right. So if YA is equal 0, then what I can say, YA is equal 0 and let me say YB is also 0. Okay, so YB is also 0. X coordinates only the remaining terms, then that is equals 4 times 4 times XA square, right? 4 times XA square. That means what I can write here is XB is equals 2 times XA, and another way is if XA is equal 0 and XB is also equal to 0, if I assume this situation, then definitely, because they are moving in same line, so simultaneously their coordinates must go change at the same rate. So for that circumstances, I can use this method. So here is the remaining terms are XB square, which is equals 4 times YB square is equals 4 times YA square. Otherwise I can write YB is equals 2 times YA. So by using these two results, I can do something here. Okay, so that is the thing what I am making now. So this equation finally rewritten as VCA vector is equals, XB is 2 times XA. So 2 XA minus XA is XA into I cap. So this is good. This holds. Because XA means X only is the available coordinate for a VCA. That means a car is moving with respect to A only along X direction, that is east. So this is correct. What the thing it is said in the question, it is right. But here let us check this one. So this is VCB, that is equals now YA minus YB. YB is 2 times YA. So the remaining terms are nothing but minus YA into J cap. This is a contradiction, right? This is a contradiction. Why it is contradiction? Because so minus Y component, that means it is moving along this direction. This is minus J. Minus J is here. So this is plus J. Just observe. This is plus J. So we are getting minus J. That means with respect to B, car is moving in south direction. This is contradiction because it said in north direction. Should be north direction. So this is not the situation. So for this, I simply redefine all the equation one more time. I already said it is not so easy to make you clear about the question. So I am going in high depth with this solution. So I am redefining all the things now. the contradictory answer we got. So in the second trial, I am now making the second trial. So in the second trial, so I am assuming VA is as it is, that means XA I cap plus YA J cap, and VB as a XB I cap plus YB J cap, and for car, so I am taking VC is equals, right, this is for car, so this is equals, what I am writing is XC I cap minus YC J cap. This is the only change I am making in the second trial. So now what we have to do is, according to the given condition, you know, the car should move to the east direction with respect to A. That means only x coordinates should change. Okay, so x coordinates should change. That means now x A is not equal to xc. This is right. With respect to A, I'm talking about with respect to A only. So this is the thing what I am doing now. So XA is not equal to XA, but now these two things should match. With respect to A, YA should be is equals to YC. This is expected. But what we are getting, so in the second trial, what we are getting YA is equals to minus YC. That means these two things are no, not possible. So because YA means the Y coordinate of A is changing positively, and the Y component of car is changing negatively. This should not happen. Otherwise, there will be a relative motion between car and so the person A. Means no, relative motion. Relative motion between car and the person along y-axis. So this is again contradiction. So this should not be. So this thing is again wrong. So we should not assume this situation one more time. So now I am doing the third trial. So in the third trial, so be careful here. So in the third trial, what I am assuming, VA is XA I cap minus YA J cap. Okay, so VB is XB I cap minus YB J cap, and VC for car it is. So this is XC I cap minus YC J cap. So assuming all these things together, so what I do tell now is, from the given condition, so I must write XC must be is equals to XA, and YC, that means minus YC is equals to minus YA. So that means YC is equals to YA. That will be now valid here in the notation. So that means what I can write here is VC is equals I can write X no XB, right? So this should be XB XB minus XA. This should be now I should take every care when I am writing. So just a minute. So what happened? So with respect to A, car should move in east direction only. That means only x coordinate should change. That means the this one xc will be different. Xc and xa are different. They are not same. But yc and y are equal. So this is right. Further, what I should say is, so I should take care here. Otherwise, this may go wrong. So the situation could be like this. So this is with respect to A. So what I am saying here, this is with respect to A. So with respect to A, I am talking now. So now if I do the same thing with B, so with respect to B, so what I must write here is uh, the y coordinate should change, right? So minus yb and yc are not equal. Yb and yc are not equal with respect to B. But what should be equal? So the equal terms are x c is equals to xb. So then all our conditions will go right. So satisfying this, then we can write. So velocity of the car c is written like, in place of xc, I write xb as I did in my first trial. Otherwise, I write I cap. Then I write, for a y coordinate, it is ya. So yc is equal to ya. So this is j cap. This is how I can write vc. So now what I can do is, now I rewrite this one, the relative velocity. So no, the relative velocity of a car with respect to A is now, so it is xb minus xa, right? Xb minus xa into I cap, and y components don't exist, they cancel. So meantime, the further calculation will allow me like this, xb is 2 times xa. So that means we see a is equals, this is x a into I cap. So this is xa into I cap. This is right. So similarly what I do is VCB with respect to B, if I do, then this is nothing but xb minus xb. So they cancel. So only the remaining terms are minus ya, right? So minus ya into j cap minus here is minus yb j cap. So all things I keep in bracket, minus yb j cap. So further what happens, VCB is equals, this is minus ya, right, minus yb into j cap. Since yb is 2 times ya, right? So yb is 2 times, sorry, 2 times ya. This is the thing what we already got in first trial. So this is true. So this is from given data, we can rewrite this one. So now VCB is simply, so what happens? It is minus of minus ya j cap. Otherwise I can write VCB is equals ya j cap. So this is also correct. So one result is here for VCB and one result is here for VCA. So we got two things, VCB and VCA. Okay, so but what we have given, you know, so the speed of the relative speed of the car with respect to each person is same. That is this one. The magnitude of VCA and VCB are same. That means what I can write. So that implies now XA is equals YA. So from these calculations, so VCA magnitude and VCB magnitude, that is XA and YA, are same. So that means XA is equals YA. This is what we are seeing. Now, from this one, the main thing is this one. Okay. So from this I can write what? Tan theta. So this will give me the direction of the velocity of the car with respect to x-axis. So this is equals minus YA divided by XB. So you must know XB is 2 times XA, 2 times XA. But XA and YA are same. So minus YA divided by 2YA, because XA and YA are same. So now these two things get cancelled. So the remaining terms are tan theta. So that is equals minus half. Otherwise I can say this theta is equals tan inverse minus half. This is the answer what we obtained finally. So that means so you must know. So from my convention, this is a north, which is y-axis, and this is a x-axis, which is east. Right. This is north. So now theta is a tan inverse half. That means it comes somewhere here. It comes somewhere here. So it is somewhere here. Here it is. So theta is equals this much what I can write. So that is now in this portion the actual direction of the car is observed. That means which is south of east, right? So this much south of east what we are seeing. That means this much angle south of east. This is correctly said in option B. So option B is exactly the correct answer for this question. In this question, so they are saying a coin is released from inside a lift at a height of 2 meters from the floor. So this is the lift. If we assume this indicates the lift, see what it is said, the height of the lift is 10 meter. So overall height of the lift is 10 meter. So from floor to the roof it is 10 meter, and the coin is released at a height of 2 meter from the floor. Say this is the position of the coin where they released it. So this height is 2 meter. Okay, so this height is 2 meter. The lift is moving with an acceleration of 9 meter per square second downward. So lift is moving downwards. Okay, so lift is moving downwards with an acceleration of 9 meter per square second. And then the time after which the coin will strike with the lift is. So now we have to find with what after what time the coin may hit the floor of the the lift. This is what we have to find. For this, we have given with the acceleration due to gravity of the earth also. So I simply mention it here. So acceleration due to gravity is also here, which is g. So this g is 10 meter per square second. We are given with this also. Okay, so now I have to find the answer for the time. Okay, so time we need. So after how much time the coin will come and hit the floor of this lift. See, the lift is accelerating downward at this much rate, whereas the coin is accelerating at this much rate because there is no relation, physical relation between contact between this coin and the lift. This coin in midair, it is airborne, and this one, the acceleration due to gravity is only now, which is acting on this one, if you say. So that means the acceleration of this lift is 9 meter per square second, whereas the acceleration of this coin downward is 10 meter per square second. So that means relative acceleration of the coin with respect to the lift is A is equals 10 meter per square second minus 9 meter per square second. So this will be is equals to 1 meter per square second. This is the relative acceleration of the coin with respect to the lift. See, it is given that it is released inside the lift. That means initially the coin is moving along with this one, the lift. So with the initial relative velocity, with respect to lift is 0. Right. So VO is 0. Initial relative velocity of the coin with respect to lift is 0. And how much displacement it has to make in order to come down and hit the floor is 2 meter. So relative displacement, made by the coin with respect to the lift is x is equals 2 meters. This is how we have to assume. So now I have to make the calculation using proper relation. So we all know the equation x is equals to VO into t plus half a t square. I simply use this equation using relative parameters. So see, this is the displacement, the relative displacement, that should be 2 meter, which is equals initial velocity, relative velocity between the coin and the lifter is 0. So whole this term becomes 0, no use, plus half into. So A stands for relative acceleration, that we already made the calculation here, which comes 1 meter per square second, right, 1 meter per square second into t square. So doing further, so this becomes, it is 2m, which is equals 1 divided by 2 into 1 meter per square second into t square. Otherwise, you can simply say no, meter that cancel. and 2 into 2 is 4, 4 seconds square. So means t square is equals 4 seconds square. Okay, so that means on taking root it will be 2 seconds. So that means after 2 seconds the coin will come and hit the floor. So t is equals 2 seconds. So this is the correct option, which is B, saying 2 seconds.